Here the two columns are given. Match the least one to the least second. According to this, which are the correct option? The first one, least one is here. Here the scientist names are given and the results are given. So the A, Frank Holz experiment, second photoelectric experiment, and the third division and German experiment. We know that according to the Holz experiment, he shows that the discrete energy levels of the atom means when the electrons are jumped from the lower level to the higher level, the energy is changes. Second, photoelectric effect. According to the photoelectric experiment, he shows that the particle nature of a light means light consists of a packet of energy. And the third division and German experiment shows that the wave nature of a electron. So in this type, the options are the first 2, 1. The first one is 2, second one is 1, and the third one is third, that is division and German. So second, third, second, first and third. So option first one is correct. So see the next question. In this next question, according to the experimental results, the photocell which is depends upon the cathode and anode. And in this experiment, the anode voltage of a photocell is kept constant, is kept fixed, means the voltage is a constant, and the wavelength, that is a lambda of the light falling on the cathode is gradually changed. Means we know that this is a cathode and this is a anode. When the electromagnetic radiations are incident on this cathode, means these radiation are consist of a packet of a energy, that is E is equal to h into nu. Means the energy is directly proportional to the frequency, but frequency is E is equal to nu is equal to C divided by lambda, that is energy is inversely proportional to the wavelength. So in this question there are 4 figures are given, 4 graphs are given. So we know that when the ratio of a current as well as a wavelength, that is a increase, in the first case increase and decrease, in the second case increases and which is a constant, in the third case increases and constant, in the third case decreases, means both are inversely proportional to each other. We know that there is a minimum frequency is required to liberate the electrons, and that is known as a threshold frequency. So when the wavelength is goes on increasing, the frequency is goes on decreasing. When the frequency is decreases below the threshold frequency, the photoelectric current is goes on decreases. Therefore, the option D is correct. Next, photoelectrons are ejected from a metal. When the light of a frequency nu falls on it, pick out the wrong statement. So pick out the wrong statement from the following questions. There are some options are given. No electrons, first option is no electrons are emitted if nu is less than W by H, means nu naught below the threshold frequency, the electrons are not liberated. Second, the ejection of a photoelectrons is instantaneous, that is correct. As soon as light radiation are incident on the cathode, the electrons are liberated within a second, and that process is known as an instantaneous process. So this is also a correct. So this is also correct. The third option, the maximum energy of the photoelectrons is h nu. So we know that E is equal to W plus kinetic energy, that is a maximum kinetic energy. Therefore kinetic energy is equal to E minus W, that is h nu minus h nu naught. Here the option is given as a h nu, means the kinetic energy is depends upon h nu minus h nu naught. So the option C is wrong. The maximum, fourth option, the maximum energy of the photoelectron is independent of the intensity of a light. Correct. That is a maximum energy of the photoelectron is depends upon the frequency, and that is does not depend upon the intensity of a light. So this option is correct. So the wrong option is C in this question. See the next question. The surface of a metal is illuminated with a light of a 400. That light is given as a wavelength lambda is equal to 400 nanometer. The kinetic energy of the ejected photoelectrons was found to be 1.68. Kinetic energy is equal to 1.68 electron volt. The work function of the metal is, find out the work function. Then we know that E is equal to W plus kinetic energy. Therefore, kinetic energy is given. To find out the work function, W is equal to E minus kinetic energy. Kinetic energy is given in the form of a electron volt. So find out the value of a energy. E is equal to wavelength is given, therefore hc divided by lambda. Lambda is in the form of a nanometer. So we know that there is a one shortcut formula to find out this value, that is a 12400 divided by lambda. Lambda is in the form of a nanometer. Convert this in the form of a angstrom, that is a 1 to 400. 400 nanometer means this is a 4000 angstrom. Convert this. shift to the point 1 2 3 point, and this also 3 points means the value is a small, and we easily calculate this value. 4 ones are 4, 4 threes are 12, 3.1. Therefore energy is equal to 3.1. W is equal to 3.10 minus the kinetic energy is given as a 1.68. Therefore, the answer is equal to 1.42 electron volt. So, the first option is correct. See the next question. Photon of a frequency nu has a momentum associated with it. If c is the velocity of the light, then the momentum is equal to. So to find out the momentum in this form, therefore we know that the equation E is equal to h nu and E is equal to m into c square. Compare both this equation. H nu is equal to m into c square. Therefore m into c square, h into nu, this c divided by c is equal to m into c. We know that m into c means nothing but a momentum. Therefore, P is equal to h nu divided by c. So, which option is correct here? H nu divided by c. This first option is correct. See the next one. According to the experimental results, we know that as soon as the electromagnetic radiation with the sufficient energy is incident on the cathode, the electrons are liberated, and that process is instantaneous. Instantaneous means within a short second, and that short second is 10 to the power of minus 10 seconds.